Hi, I'm Kai. Welcome back to ClearKai. You've already learned how to solve linear equations and even handled some trickier ones with fractions, parentheses, and exponents. Today, we are taking it one step further into advanced algebra equations. These are the ones that involve fractions with variable in the denominator, called rational equations, and square roots or cubic roots, called radical equations. Don't worry, we will use the exact same logic you've already learned. Simplify, isolate, and solve, just with a few extra steps. Let's get started. Before we jump into advanced equations, let's take a quick review of what we already know. Every algebra problem, no matter how big or scary it looks, really comes down to just two steps. Step 1, simplify both sides. Step 2, isolate the variable. That's it. Simplify then isolate. Let's look at this example. 3x plus 5 equals 14. Subtract 5 from both sides. That gives us 3x equals 9. Then divide both sides by 3, and we get x equals 3. You've used this process for linear equations, and now we will use the same logic for equations with fractions and roots. The steps stay the same. They just take a little longer. Here's our next advanced example. A fraction equation with variables on both sides. We have 4 over the quantity x plus 1 equals 1 over the quantity x minus 2. When variables appear in the denominator, the key trick is to get rid of the fractions completely. To do that, we multiply both sides by the common denominator, that's the product of x plus 1 and x minus 2. Watch what happened. The denominators canceled out. On the left, we are left with 4 times the quantity x minus 2. And on the right, we have 1 times the quantity x plus 1. Now it looks just like a regular linear equation. We can simplify and solve the same way we always do. No more fractions to worry about. Now that we've cleared the fractions, this looks just like the linear equations we practiced before. We start with 4 times the quantity x minus 2 equals 1 times the quantity x plus 1. Let's distribute. 4 times x gives 4x. And 4 times negative 2 gives minus 8. So the equation becomes 4x minus 8 equals x plus 1. Next, we isolate x. We will subtract x from both sides and add 8 to both sides. That gives 3x equals 9. Finally, divide both sides by 3 and we get x equals 3. So even though it looks complicated at first, we used the same two steps. Simplify, then isolate, and it worked perfectly. Now let's look at a problem that has square roots, or what we call radicals. We start with the equation 1 over the square root of x plus 1 over 2 times the square root of x equals 6. This looks complicated, but it's actually just another fraction equation. We can clear the denominator the same way as before. To make those roots disappear from the denominator, we multiply every term by 2 times the square root of x, which is the common denominator. So we multiply both sides by that. That gives 2 root x times 1 over root x becomes 2. Then 2 root x times 1 over 2 root x becomes 1. And on the right, 2 root x times 6 becomes 12 root x. So now our equation is 2 plus 1 equals 12 root x. Combine the left side and we get 3 equals 12 root x. And now we're ready for the next step, isolating the square root, just like we isolate x in regular equations. Now let's finish this radical equation step by step. We start with 3 equals 12 times the square root of x. To isolate the square root, we divide both sides by 12. That gives the square root of x equals 1 over 4. Now, to get x by itself, we undo the square root by squaring both sides. So, x equals 1 over 4 squared, which is 1 over 16. And that's our final answer. X equals 1 over 16. Remember, when solve radical equations, treat roots like variable first, then square at the very end to isolate x. Now let's look at our third problem, a mix of fractions and variables. We start with 2 plus open parenthesis x minus 3 close parenthesis divided by 5 equals 4 plus x. Since we have a fraction, we will clear it by multiplying both sides by 5. That gives 5 times 2 plus 5 times open parenthesis x minus 3 close parenthesis divided by 5 equals 5 times open parenthesis 4 plus x close parenthesis. Now the denominator cancel, leaving us with 10 plus x minus 3 equals 20 plus 4x. Next, we simplify the left side. 10 minus 3 gives 7. So we have 7 plus x equals 20 plus 4x. At this point, we've cleared the fractions and combined the terms. We will solve for x in the next step. But the key idea here is simplify your mixed terms before solving. Now that we have simplified the equation, we have 7 plus x equals 20 plus 4x. Let's get all the x terms on one side and the numbers on the other. We will subtract x from both sides and subtract 20 from both sides. That gives 3x equals negative 13. Finally, divided both sides by 3, and we get x equals negative 13 over 3. So our solution is x equals negative 13 over 3. Even when the equation looks messy with fractions at first, once you clear the denominators, it becomes just a regular two-step equation. Simplify and isolate. Now let's look at the square root equation. We start with the square root of 3, open parenthesis, x plus 5, close parenthesis, equals 6. When you see a square root, the opposite operation is to square both sides. That's how we make root disappear. So we square both sides. Open parenthesis, the square root of 3 times open parenthesis x plus 5 close parenthesis squared equals 6 squared. That gives us 3 times open parenthesis x plus 5 close parenthesis equals 36. Then we distribute the 3. 3x plus 15 equals 36. And now it looks like just a regular linear equation again. Ready to solve with the usual simplify and isolate steps. Now let's finish solving the equation. We have 3x plus 15 equals 36. Let's subtract 15 from both sides. That gives 3x equals 21. Next, divide both sides by 3 and we get x equals 7. So our solution is x equals 7. When you have a square root in the problem, remember, squaring both sides is the key to remove it. And after that, it's just regular algebra again. Here's our last example. This time, we are working with a cube root. We start with 2 times the cube root of x plus 3 equals 9. The first step is to get the cube root by itself. So let's subtract 3 from both sides. That gives 2 times the cube root of x equals 6. Now divide both sides by 2 to isolate the cube root. That gives the cube root of x equals 3. To undo a cube root, we do the opposite. We cube both sides. So x equals 3 cubed, which is 27. And that's it. X equals 27. Once again, we isolate the radical first, then use the opposite operation to remove it. Same strategy every time. Isolate and undo. Let's take a quick recap of what we learned in this lesson. First, when two fractions are equal, cross-multiply to get rid of the denominators. Second, always clear denominators early. That makes the problem much easier to work with. Third, combine like terms before squaring. It keeps your work clean and prevent mistakes. Fourth, watch for extraneous root. Sometimes when we square both sides, we can create a solution that doesn't actually work, so always check it. And finally, check your answer by substituting it back into the original equation. Even the hardest algebra problems follow the same ClearKai logic. Simplify, isolate, and solve, one clear step at a time. We've walked through some really tough algebra equations. So next time, let's switch gears to something you actually use every day, percent. You will learn what percent really means, how to calculate it, and how it showed up in real life, from grades to discounts to price changes. For example, we will answer questions like, what percent of 20 is 15? Next time, we will make percent crystal clear and see how it connects right back to the algebra you already know. This is ClearKai, where learning is made clear, one step at a time. If this lesson helped you see algebra a little more clearly, remember to like, subscribe, and join me next time for our new topic, Mastering Percents. See you in the next lesson.